Hi, I'm Lorenzo Ariemma, and I'm going to present a comparison between two network emulation systems, Netkit and Kathará. Netkit was presented at TridentCom 2008 and allows to emulate complex networks, leveraging on user mod Linux virtual machines. The first version of Kathará was presented at NOMS 2018. It is an evolution of Netkit which leverages on Docker containers. Recently, Kathará has been rewritten to overcome some implementation limitations and to add support for several virtualization technologies. The aforementioned tools share the same basic concepts. First, the device, that is a virtual entity which acts like a real network device. Second, the collision domain, that is a virtual layer 2 LAN that interconnects devices and acts like a physical link between the devices' interfaces. And third, the network scenario, a set of devices connected by means of collision domains. Regarding network scenarios, they are described by a specific network-oriented language, simple to understand and to learn. A network scenario is represented by a folder which contains a file called lab.conf, describing the topology. As you can see, each line of the file contains the device name, the interface number of that device, and the collision domain which it is attached to. Moreover, for each device, there is a .startup file which contains shell commands that are executed on device bootstrap, and a folder whose content is copied in the device root directory on deploy. As an example, the startup files assigns IP addresses to network interfaces, while the folder contains the routing daemons configurations. We describe the network scenario that will be deployed for the comparison of the tools. It represents a simple autonomous systems hierarchy. There are 5 autonomous systems. AS1 is a tier 1, AS20 is a transit AS running OSPF, while AS30 is a simple transit AS. AS20 and AS30 also share a peer-to-peer link between them. AS100 is a multi-ohm stub AS running RIP and hosting a web server, and AS200 is a multi-ohm AS hosting a client. The client is able to reach the web server leveraging on a full DNS hierarchy deploying in the network scenario. The comparison is performed on 3 different virtual machines with the same resources. Each virtual machine runs Debian 10 and is provided with 8 virtual CPUs and 8 GB of RAM. Each network emulation system will deploy the same network scenario described previously. On the top left of the screen there is Netkit, on the top right of the screen there is old Kathará, and on the bottom left of the screen there is new Kathará. 3 videos are synchronized so it is possible to compare the time needed to deploy the network scenario. As you can see, new Kathará has the best startup performance, followed by Netkit, and then old Kathará, which takes more than 3 times than the new Kathará. This is due to the single-threaded implementation of old Kathará. The startup is a transient, so it is meaningless to compare CPU and memory usage in this phase. However, it is very useful to consider CPU and memory after the network scenario has been deployed, since these resources have to be available on the host in order to ensure smooth performance. Now, we are running the commands to get the resources used by each device on each emulation system. Observe that old Kathará and new Kathará show comparable result, since they both share Docker as virtualization technology. On the other hand, Netkit uses a lot of RAM because it leverages on fully fledged virtual machines with multiple kernel instances. At this point, the 3 emulation systems put at users' disposal a network scenario that can be exploited to run experiments and tests in an isolated environment. We use client in AS200 to open a web page stored into the web server using links. We use new Kathará to perform tests, since the tools behave the same. As you can see, the network is fully functional. BGP runs and converges using the Quagga suite, and the old DNS hierarchy is configured using bind. Now we measure the time needed to undeploy the network scenario. As previously, new Kathará outperforms the other tools. In conclusion, since Kathará is mainly based on Docker containers, it supports any Docker image, giving the possibility to install and use any software supported by Linux. For example, switching facilities like P4 and OpenFlow, routing suites like Quagga and FRR, or general applications like a DNS server or a web server. Thank you for watching.